今日は僕たちは、アイオニックイクイブリアムを勉強します。Yeah. So, we are going to study first in ionic equilibrium. What is an electrolyte? Electrolytes are the substances which conduct electricity in molten state or in solution. That's simple, right? Electrolytes are the substances. This is like common sense, but still, you know, uh, as a matter of fact, as a matter of stating of axioms. Okay, this is basically a definition. Conduct electricity. Basically, it's true that they dissociate into ions, and then they conduct electricity. So that's an electrolyte, but you get the point. Now we're going to study the Arrhenius theory of electrolytic dissociation. Okay. So according to the Arrhenius theory of electrolytic dissociation, let me tell you, when electrolyte is dissolved in a solvent, it spontaneously dissociates into oppositely charged particles called ions to a considerable extent. We knew this, we just don't know the name Arrhenius, or probably we knew this from Arrhenius Olsen base, acetone base, and that's what we have been studying in 10. But anyways, when an electron is dissolved in a solvent, it spontaneously dissociates into oppositely charged particles called ions to a considerable extent. Of course. Now, I don't know if it's something to remember, but yeah. Since the solution of an electrolyte as a whole is electrically neutral, the total charge of cations is equal to the total charge of cations. Wow! Electrolytic ionization or dissociation gives ions and unionized molecules in solutions. Electrolytic ionization or dissociation gives ions and unionized molecules in solution. Obviously. Yeah, obviously. So actually these are the things that we are taught intuitively in class 10th. We're not given the reason or who gave the theory or where is it formally stated. I used to doubt this thing that do they really separate out in the solution to the ions or they separate out only when electricity is giving out something like that. But the thing is actually they always separate out and I did not have 100% guarantee of this because they never told me that it is called Arrhenius theory. If they had told me that it's a theory given by scientists, I would have agreed. I mean, I could have been confident in that. And also the other 2 points, like electrical neutral is common sense, but then you have ionized and ionized molecules, that is also common sense. But you get the point what I'm talking about, right? Now, the only mathematical thing we're going to study is degree of dissociation. It is a fraction of 1 mole of an electrolyte that has dissociated under given conditions. The value of alpha depends on temperature, dilution of electrolyte, nature of electrolyte, and solvent. Okay. So, to take 1 mole of an electrolyte and it has dissociated under the given conditions. Okay, the fraction of 1 mole. So, like total number of moles, out of the total number of moles, how many moles have ionized? Dissociated into their respective ions. That is alpha, the degree of dissociation. Actually, I've studied this in class 10. I don't know about you, but at least me. We'll study it for. I actually studied it for the concepts which I'm going to study next. I studied until short to study acid and bases, and that's not what we're going to do next. Okay, so the fraction of 1 mole of the electrolyte that has dissociated under the given conditions. The value of alpha depends on temperature. So this is definition, right? 1 mole of electrolyte that has dissociated under the given conditions. Yeah. Next thing is, okay, so yeah, I was saying we have the definition of degree of dissociation which is denoted by alpha, but the thing is the value of alpha depends on temperature, dilution of electrolyte, and nature of electrolyte and solvent. Temperature, dilution of electrolyte, nature of electrolyte, and solvent. Of course, like how much does it dilute, and then we have how much. What is the temperature? Because more the temperature, more dissociation is happening easily because we're giving more energy, something like that. And dilution, of course, nature. Do we have like strong electrolytes or weak electrolytes? And then solvent. So like you have solvent which has more. We have this word called, I think, dissociation potential or something. We'll understand later. So you get the point for what I'm saying. Next, we are going to look at the Oswald's law of dilution. Now we have a law, we have a theory, we have a definition, now we have a law. What does this say, by the way? Oswald sound like Oswald, but it's actually Oswald's. Oswald's. Anyways, this law deals with the application of law of mass action. If AB is weak binary electrolyte containing C moles in 1 liter. Okay, so this AB and it contains C mole initially, and then it is getting converted to A plus and B minus, and it's weak, so I'm getting 100% dissociated. So there's something like coming back as well, right? You think when it's 100% dissociation is not happening, it's by common sense that something is coming back. Let me explain this to you. एक कहानी जो सबको सुनानी करने वालों को जलानी है. Anyways, what were I saying? So I was saying, if AB is dissociating into A plus and B minus, let me laugh. If AB is getting dissociated into A plus and B minus, then we have initial concentration C of AB and A plus and B minus have zero concentration, obviously. Yes, I was saying that we have this A plus and B minus, and if it's a weak electrolyte, see, suppose there are thousands of atoms. Thousands of, not atoms, basically molecules, okay, or compounds, and they want to dissociate, but it's a weak electrolyte. So what do you think will happen? I mean, you will say that by definition or by whatever we know, some of it will dissociate, but which some of it will dissociate? Now you might say if it's in a container, probably the bottom ones because they get more heat or something like that. But assume that there's nothing like that. It's an ideal condition. Which one do you think will get dissociated? No. All of them could get dissociated, and I think it's not like they will be chosen by probability, they will get dissociated simultaneously. But once they'll get dissociated, they'll also want to get back associated. Okay. So that's why it's weak. It's weak because they want to get back associated, not because it's not dissociated completely, because it wants to get back associated. Actually, probably everyone wants to get back associated. I'm not sure about that. If someone really has alpha of 100%, but I can say that, yeah, it's actually the reverse reaction, the backward reaction, back association, and that makes something weak. Now it's saying that if we have concentration at C, 1 minus alpha, let's say alpha is 100%, 1 minus alpha is going to be 0. Yeah. So if alpha is 100%, but alpha can't be 100% because it's weak. So if C minus Ca, okay, is the concentration of AB after some time, actually at equilibrium, then the concentration of A plus, A positive will be Ca and B minus will be Ca. Now does it make sense? Probably it does. If you add all of them up, what do you think you'll get? Well, basically, you won't get the same thing. Because, no, you won't get the same thing. Sorry. So that's the law. It says that the concentration at equilibrium is going to be C1 minus alpha of the reactant which is getting dissociated, and the products will have C alpha and C alpha. Yeah. I don't know how it makes sense. I'll think about it later. And the concentration, like K, the K will be given by obviously A plus B minus concentration divided by AB concentration, which will be C alpha into C alpha divided by C minus C alpha. It's going to be C alpha square divided by 1 minus C alpha. C is the concentration, alpha is the degree of dissociation, obviously. Now this expression is called the Oswald's dilution law. K of particular equation. By the way, what was the definition of the K? Yeah, the rate of reaction. Anyways, is given by C alpha square minus 1 upon alpha. Now, Before we go on this equation, I would like to think for a minute about this C alpha and C alpha. Is it intuitively provable? Let's see. Yeah, so we were finding out if it is intuitively provable. Suppose you have HCl. HCl gonna say this. No, we can't have HCl. Give me an example of a weak one. H2SO4 is somewhat weak, I guess. HNO3. Let's assume acetic acid. It has, I think, CH3COOH. Yeah. It is into CH3COO minus and H plus. Now, the concentration at the beginning of the whole thing, let's say it's C. At equilibrium. What does it mean by equilibrium, by the way? Equilibrium means no more ions are being formed, right? If no more ions are being formed, the concentration will definitely remain constant. We're just asking what will be its value. So, degree of dissociation is what? It's number of moles divided by total number of moles. Now, if HNO3 is dissociating, out of C, if the C, we know that C is directly proportional to number of moles, and alpha is directly proportional to number of moles ionized. So if we look at the product, C and alpha are directly proportional. Are they? Alpha is directly proportional to the number of moles ionized, of course. It's actually the number of moles ionized divided by something. Wait a minute. Total number of moles has to be directly proportional to C, right? C is N upon V and alpha is, let's call it N of product NP by V, right? Isn't it? NP by V? No, NP by N. Okay. एक कहानी है जो सबको सुनानी है. Okay. Now, if that is the alpha, NP by N, then what relation can you get between C and A? I think basically C into A alpha will definitely be NP upon V. Wait a minute. We've actually proved it, haven't we? Yes, we have proved it mathematically. By which sense is Oswald's law a law? Because A is equals to NP, N of product divided by total number of moles, and C is equals to N into V, and if you multiply these two, N will get cancelled, and then we have NP upon V, that is the number of mole of product divided by volume, and that is definitely the concentration of the product again. So that's what we have to prove. So yeah, it's proved. I will know about it because next I will you about it. Why should the concentration at equilibrium of the reactant be C 1 minus alpha? Well, that's a nice question. Let me think about it. If the C is the initial concentration of it, and then alpha is the degree of dissociation, and C refers to again N by V, alpha refers to NP by V. And no, it refers to NP by N, and if we subtract it by 1, so that's basically. Yeah, so where were we? I'm sorry. It's not about balloons what we are studying. Yeah, so I was telling how come the concentration of AB, which is the reactant, is C1 minus alpha. So it's again very easy. Let me tell you. The same thing, I don't know by what standards Oswald called this a law. Because it's not a law, I think it's by we are deducing formula from definitions. So next, just a second. So firstly, how much is 1 minus alpha? 1 minus alpha is going to be the total number of moles minus the moles of product, because alpha is the moles of product divided by total number of moles, right? You're getting it, right? N upon N minus N upon NP upon N. So that's going to be N minus NP upon N. And then multiplying it by C means multiplying it by N upon V. N means the initial volume, initial concentration, definitely, of the reactant. So N minus NP is going to be NR, obviously, and then NN is going to get cancelled, and NR is actually the fine at the equilibrium concentration of the reactant divided by the volume, which is going to be the concentration, the final concentration of, yeah, that's right, the final concentration of AB. But instead of doing what we had done, could we do something else as well? I mean, could we prove it the other way around? I think this is good. This is good. But I can actually prove it the other way around. Its concentration is basically the number of moles which are there divided by the total volume. And definitely we can use C and alpha to get it, and then we can use all of this to get the KEQ, which is here going to be CA square uh, 1 minus alpha. Now this is actually also common sense, but you get it right. Yeah, so yeah, so let us continue. We have our uh, definitions and we have our small proofs, right? Nice proofs. Now, also, C is N upon V, right? So the another equation, which is just a second. Now, if we fix the volume to be that much volume which contains 1 mole, then C is equal to 1 upon V, right? Yeah, because number of moles is 1. So we can do that as well and get another equation just for the sake of another equation so that we can solve more questions. Yeah. V is the volume of the solution in liters containing 1 mole of the electrolyte. I repeat, everything is happening in the electrolyte and not in the solvent. You don't have to care about the solvent. When I mean V, I actually mean the I obviously actually mean the volume of the solution, right? Okay. Now that's why it remains constant throughout the thing, and we only compare the moles. Now, if alpha has very small value for a weak electrolyte and is therefore negligible in comparison with unity, then 1 minus alpha is close to 1, so the whole thing is going to get converted to a square c, and things are going to be simple. It's going to be tough. I don't know. If a minus alpha is equal to 1, then it's going to be close to, yes. And then we can have, we can have this beautiful equation here. Uh, Alpha is equals to KEQ upon C root. Not very beautiful, but indeed beautiful. And that is also V, so we have another form of this. I don't know why when we are going to use, but yeah, we have. So yeah. Okay, so we have a lot of equations. These are called the Oswald's law of dilution. Firstly, we have KEQ, which is going to be C into alpha square upon 1 minus alpha, which we can easily derive as we have derived. And then we have alpha is equals to KEQ upon C if the 1 minus alpha is very small, that is, alpha is close to 0. Then, actually, whereas alpha is close to 1. This is Oswald law of dilution, just this thing. Now, next we come to the concepts of acids and bases. Basically, there have been many concepts given upon acids and bases. We have the Arrhenius concept, the Bronson-Lowry concept, the Lewis acid and bases concept. We also have I think we have one more concept. Anyways, we're going to study only these many. Okay, so Arrhenius concept is very easy. Any substance which is dissolved in water increases the concentration of H plus, it's acid. If it increases the concentration of OH minus, it's base. That's as simple. We have been studying this, easy. But Bronsted Lowry concepts gives it a new point of view. It says species that donates a proton to another species' acids, and the species which accepts a proton from another species is a base, which is a beautiful definition, which is actually a little confusing, but it's good. Now, why we needed this definition is because Arrhenius definition are their Janice definition and Bronson law definition are generally equivalent in aqueous solution, but NH3, what do you think it is? Well, it is basic oxide or something. Not basic oxide, basic gas or something. And how do we say it's a base? It's actually a base because it can accept a proton H plus to give NH4 plus and Cl minus. If it reacts with HCl, does that even make sense? Well, yes, it does because then it forms NH4Cl, right? So yeah, but it does not form any. It forms a salt, but it does not form any water. What type of a reaction is that? But it still accepts a proton, so be happy if you want to be. So yeah, really, they have different points, even though they give a certain equal concept. They have different points. Now, what is Lewis acid and bases? Lewis acid, Lewis acid is an electron pair acceptor and a Lewis base is an electron pair donor. Complicated definition. Now we need to understand this that giving and taking a proton is basically taking a proton but no electrons. Well, as accepting a proton is basically giving is basically yes giving a lone pair, because if an electron comes, the way leaving a lone pair to the proton to form a hydrogen out of it. So yes, Lewis acid is an electron pair acceptor because it takes the electron pair in the sense that if you have HCl, it I think we need to look at the examples. Also, an acid-base reaction is the sharing of electron pair with an acid by a base. This process is simply defined as coordination or neutralization. Acid-base reaction, that is a coordination or neutralization, is the sharing of electron pair with an acid and a base. Now, what is a Lewis acid? Lewis acid is cationic. Generally, cations act as Lewis acid.